Okay. All right, so today what we are doing is on topic 5. So topic 5 there is where you start off with your statistical hypothesis testing. Okay. For the rest of it, in fact, for the rest of the semester, you'll be doing with hypothesis testing. So let's go to this concept of statistical hypothesis first. Statistical hypothesis is actually formed from your research hypothesis. In order to form your research hypothesis, you actually start off with your research question. What you want to find out? From research question, you form your research hypothesis. Okay. But research hypothesis itself is actually not testable in a sense. So from research hypothesis, you have to form what is known as your statistical hypothesis. And the most important part about statistical hypothesis is it comes in pairs. So statistical hypothesis is always you have your null hypothesis and your alternate hypothesis. It has to come in pairs. Usually, null hypothesis we denote it as H0, alternate hypothesis as H1. Null hypothesis is generally the hypothesis of no difference. Okay. For example, what does no difference means? Okay, you are saying that, let's say, drug A does not affect cell growth. So that is the kind of hypothesis of no difference. So alternate hypothesis is actually generally that there is a difference. Okay, such as, for example, the drug A affects cell growth. Okay. So you always need to have null and alternate hypothesis at the same time. The purpose of hypothesis testing is then to find out what. So let me just write from here. So that is the whole purpose of hypothesis testing. It's actually to use your data to find out what is the probability that the null hypothesis is true. Okay. You want to find the probability that the null hypothesis is true. This is the important part. Okay. So from there, this probability, you then compare with the threshold. So the threshold is a passing mark. The end result will be this. If the null hypothesis has a, in quotation marks, high chance of being true. Okay. Then we fail to reject the null hypothesis. By failing to reject the null hypothesis, therefore, you accept the null hypothesis. On the other hand, if the null hypothesis has a low chance of being true, then we reject the null hypothesis. By rejecting the null hypothesis, you accept the alternate hypothesis. So essentially, what does statistical testing really do is you have your research data, you calculate a statistic to see whether is null hypothesis likely to be true or alternate hypothesis may be true. So you can only reject null hypothesis if null hypothesis is not likely to be true or low chance of being true. This chance is actually depending on the threshold itself. If you reject it, then you go to alternate hypothesis. If you cannot reject it, then you accept the null hypothesis. You stick with null hypothesis. So far, okay? So this is the whole concept of hypothesis testing. You can think about this threshold like your passing mark. So your statistic, the statistic that you calculate, is like your exam marks. If exam mark doesn't meet the null hypothesis, doesn't meet the passing mark, you fail. It's over, you pass. Right. So in other words, we set the null hypothesis. Here we set the null hypothesis to be rejected. It is only when we say that drug A is unlikely not to affect cell growth, then we reject it and we say that it affects cell growth. Make sense? So the basis is drug A has no effect on cell growth. That means you put drug A, you put the drug or not, there's no effect on cell growth. It's because the end result shows that when you put drug A, there is an effect. So the likelihood of not having an effect is actually very low. Therefore, you reject the null hypothesis and say that it actually affects cell growth. But if drug A only affects the cell growth very slightly, it may be due to chance, then you cannot reject it. Okay. Now, in this context, the first thing is you always have to set the hypothesis correct. Which also means that if there's no difference, your null hypothesis is always you have a value equals to another value. Okay. Because does not affect, no difference is equal to. Alternate hypothesis in this case, if there's an effect, means that it can be, and they'll tell you that it's promoting cell growth or killing the cells. So it could be not equals to another number. That means it can be more than or less than. Or if it can be more than or less than, then this we use we call it a two-tailed test. Sometimes you only bother about more than or less than, either way. Not both ways. This is called a one-tailed test. So that is the whole concept of hypothesis testing. Okay, it may sound a bit abstract, but you will just be doing it time again for the rest of the semester until you get used to it. And that's actually the rest of the semester already. You're just doing hypothesis testing after hypothesis testing. Now you're learning the different tools to do hypothesis testing. Today we only learn two of them. Your one sample t test and one sample z test. Okay, so for any problem? Anybody want to take a photo? But clean off. Okay, then let's continue. Okay. So we go to the steps of doing hypothesis testing. Okay, hypothesis testing basically follow a fixed defined number of steps. Okay. Step number one, you have to define the null and alternate hypothesis. You start off with what is a hypothesis first. Okay. Then after that, you have to define what is the threshold. So this threshold is the alpha value. So you define a passing mark. Okay. From there, the third, you collect your data. Okay. Usually, we will not do this in this module. You collect the data, you know how to collect for experiment and all this stuff. But the purpose of collecting the data is then to figure out what test to use. So you can put this as step number 4 if you want to. What test to use? So from the test, you actually, so it's from 3 and step 4, you calculate a statistic. Now then step 6 is from alpha. So from step 2, which is your alpha, okay, and your step 4, the test to use, you calculate what we know as a critical value. Then step 7, from the results of 5 and 6, you interpret. Okay. Interpret meaning to say that you either reject the null hypothesis. By rejecting null hypothesis, you accept the alternate hypothesis, or you fail to reject the null hypothesis, therefore you accept the null hypothesis. So what are the calculations you need to do? This is to calculate the statistic. Then you calculate the critical value. These are 2 calculation steps. Okay. Now, while these steps of hypothesis testing is pretty standard, in reality, for every kind of result, every kind of data you have, in fact, for the rest of the semester, when you do any form of hypothesis testing, the only thing that change is really these 3 steps. Because it's from what test to use. The type of test will tell you how to calculate the statistic, how to calculate the critical value. Once you have the statistic and critical value, just interpret. So far, so good. Okay, again, to allude to you, what are all the tests that you'll be doing? What are the options? The types of tests. Okay. You have your one sample stack test, one sample T test, two samples stack test, two samples T test, with your CAT T test, your one-way ANOVA, chi-square test, test. Wilcoxon rank sums test. Fundamentally, these are all the 10 tests that you will be dealing in this module only. So you have to learn all the 10 different ways. That is for the rest of the semester already. Right? So you can do this well, you can pass this semester, you can pass this module, otherwise I'll see you next semester, next year. Quite simple actually. So today you make sure that you know how to do the steps. All right. So let's look at here. What we are going to do is just the first two. So all okay here? Rather than giving you talking anymore, I'll show you an example. So let's deal with question number 3. Okay. What do you have for question number 3? Let's take down what we know. The bus company claims that the average waiting time is 5 minutes. Okay. However, the ministry thinks the company is underreporting. Okay. Now, Transport Ministry doesn't care if you're over-reporting. Over-reporting means that you report that the average waiting time is 5 minutes, but actually the average waiting time is just 2 minutes. So everybody is happy. Okay. But if it's under-reporting, you publish that the average waiting time is 5 minutes, while everybody wait for 10 minutes. Then everybody is not happy. Okay. So what they do? They collect 100 waiting times. Okay. And the result is that the mean from here, the mean waiting time is 5.5 minutes. Standard deviation is 2.7 minutes. So the question is, whether the company is underreporting. These type of questions is what I tend to call as the quality control questions. In fact, when you do your SIP, you could be asked to deal with this type of quality control questions. The quality control question comes in what way? For example, how many of you like to eat ice cream? Okay. Or how many of you drink milk? Okay, what is, okay, for example, let's say your let's say your Meiji. Okay, Meiji states that each carton, or rather, each bottle of chocolate milk is 450 milliliter. Okay. Your question is whether the company is correct. It means it's a company overcharging you, that the actual volume is less than 150. So what do you do? What do you do? You go and buy, let's say, 20 bottles and find out the average volume and the standard deviation of volume. Then you calculate everything else, follow as what we are going to do here. Okay, so this is all the quality control type of questions. In fact, your tutorial 5, 6, 7 will come back to this type of question again. So let's see, how are we going to do this? But number one, what is our hypothesis? Our null hypothesis is null hypothesis of no difference, which means that the average waiting time is 5 minutes. Please write the unit. If you don't write the unit, in test, I'll just keep minusing marks from you. I ever in statistics test, for every lack of unit, I minus half mark. Okay. Or if I'm in a more horrendous mode, if there's no unit, I just cut off half of the marks. Yeah. So you give me 5 what? 5 hours, 5 minutes, 5 days, or what? So it depends on which side of the bed I roll out from. Maybe. Okay. So my alternate hypothesis is that the ministry thinks that it's under-reporting, which means the average waiting time is actually should be more than 5 minutes. Okay, and that gives you a one-tail test. The alpha is 0.05. Okay, the question asks you for 5% significance. So now we have settled part 1 and part 2. Okay. Part 3 is done, because part 3, the question tells you that the sample size is 100. The mean waiting time that you collect is 5.5 minutes. And the standard deviation of waiting time is 2.7 minutes. Okay, so step 1, step 2, step 3 done. The first 3 steps. Now, step 4 is the most important one, which test to use. I shouldn't use red. So I need red again. So let's use black. Okay, so step 4. What test do you think I should use? You have only 2 tests. Z test or T test? Which test do you use? Huh? Why Z test? Correct. So, yeah. So you say that since sample size is more than 30, you can use your Z test. So you decide Z test already. From there, we start to calculate. So how do we calculate the statistic? Step 5. The statistics for Z test is a Z score. And the Z score tells you that it is the average minus the mean divided by your standard error, which is essentially the average minus of the mean Standard error is your standard deviation divided by square root of n. So you have 5.5 minus 5 divided by 2.7 over square root of n is 100. Okay. That gives you about 1.85, around there. So this is the value, 1.85. Then step 6, you have to calculate the critical value. Critical value simply means that if you have a normal distribution, okay, and you want, it's only one tail test, so it's if the right tail, this area is 0.05. What is this value here for Z? So from here, what you have is Z 0.05. The critical value will be 1.65. So you go to the Z distribution table, 0.05 to the 1.65. So this is the critical value. Then after that, you interpret the results. Based on these two, you interpret the results. Do you accept or reject null hypothesis and why and what it means? Okay. Now, in order to interpret the results, let's have a very simple rule. How do you interpret the results based on the statistic and the critical value? So these two. The rule is actually quite simple. You follow one of these two. If the statistic is more than the critical value, that means the actual statistic is more than critical value. What do you think is the area? Is it more than or less than 0.05? If the statistic is more than the critical value, that means if this is the critical value, but the statistic is actually here, do you think the area shaded is less than or more than 0.05? So if okay, so what I'm trying to say is here, this number here is actually 1.65, but at 1.85, do you think the shaded area is more than or less than 0.05? Less than, right? Because it's less than 0.05, the chances of null hypothesis being correct is less than 5%. So it's actually low. If the statistic is more than critical value, it simply means that the probability that your null hypothesis is true is less than your alpha value. Okay. Therefore, you reject the null hypothesis. Automatically, the converse is true. So if the statistic is more than the critical value, this means that the probability of null hypothesis is true is actually more than your alpha. Okay, more than alpha means that you fail to reject your null hypothesis. Okay. So in this case, is it situation 1 or situation 2? Statistic, critical. Is it will it be 1 or 2? 1, right? Okay. So then you write your conclusion. Since Z is more than Z critical, okay, you reject your null hypothesis. Once you reject your null hypothesis, you have to accept alternate hypothesis. Hence, you accept alternate hypothesis. What does alternate hypothesis means? Go back to answer the question. Therefore, the bus company is under 14 the waiting. That's good. How many marks do you think this question is? 10 marks, correct. So where are all the marks? We have 1 mark here, 2 marks here, 3 marks here, 4 marks here, 5 marks here, usually 6 marks will give you here. This is the right test, 7. And then here is 8, 9, and 10 marks. That is mainly a mark allocation. Okay. We can allocate slightly differently as well. But more or less, this is where your mark allocation. So your conclusion and interpretation is very important. Okay. Try to digest this for a little while. So also good? Okay. Now, let's do question number 4. Okay, question number 4. How to do it? Okay. It says that a recruit can do 7 pull-ups, essentially. Okay. And Sergeant Rambo thinks that the recruit undergoing his training is more than 7. Okay. So Rambo thinks that the average is actually more than 7. So what you do is you collect 20 people trained by Sergeant Rambo and ask them to do how many pull-ups. So tabulated the mean, rather the average should be more than 7. Okay. The mean is 7.3. Standard deviation is 4.1. Okay. So your question is, is there enough evidence to support Rambo's claims at 5%? Okay. Let's do that one at a time again. Your hypothesis. Your now hypothesis is that the average is 7 pull-ups. Sergeant Rambo claim is that it should be more than 7 pull-ups. Okay. Alpha is given 5%, so it's 0.05. You also collected your data. N equals to 20. 7.3 pull-ups. Standard deviation is 4.1 pull-ups. Okay. Part 4. What test to use? T-test. Why? Right. So sample size is less than 30. You use T-test. Nothing very much. After that, step 5, you calculate the statistic. Yeah. Okay, so actually in order to use Z-test, by right, you need 2 things. One is you need population variance and actually you need more population variance and sample size. Okay. But if sample size is more than 30, then the sample variance will be close enough to population variance. It will be a bit fuzzy, yes. Right. So if there are people who tend to use, if sample size is more than 30, but you do not know population variance, you still use T-test. Nothing wrong with that as well. So in this case, this is the decision tree that we have. What test to use? The first thing that is population variance known. Okay. If population variance is known, then you can use your Z-test. If population variance is not known, then the next thing is sample size more than 30. If sample size is more than 30, you can use Z-test. Otherwise, you use T-test. Okay. This is the kind of decision tree you have. The only subjectivity is some people, including myself, if I were to do that, I will still use t-test for this, just to be on the safer side. Okay, but as far as this module is concerned, use test. Okay, so we're up to here. Okay, so you calculate the T statistic. The T statistic is actually the same formula as your Z statistic, which is 7.3 minus 7 over 4.1 divided by square root of 20. So this gives you 0.327. Step 6, you need the critical value. Now, critical value for t-test, for t-distribution, you need one more thing that is called the degrees of freedom. Okay, now what is degrees of freedom? What is degrees of freedom to you? Matthew, what is degrees of freedom? In this case, yes, it's n minus 1, but may not always be n minus 1. Yeah, may not be n minus 1, but in this case, yes, it's n minus 1. May not always be n minus 1, huh? Okay, so while you're online, those who are online, can you go and Google what is degrees of freedom? What is degrees of freedom? Quick, somebody. What is degrees of freedom? Can somebody read out? It's fine if you do not understand. Nobody understands what it's trying to say. So anybody read from the Wikipedia, the first sentence of it, and actually understand what it is trying to say? No. You understand what it's trying to say? So what do you think it's trying to say? Okay. So in short, degrees of freedom is actually the number of samples or number of data points that can vary. So it's why is it comes to n minus 1? So let's say you have you have 20 samples. So you have 20 data points. How come degrees of freedom is 19? That means 19 can vary. So let's do a quick test. I want you to give me random numbers. Can be positive, can be negative, how big or how small, I don't really care. And these 6 numbers can add to 100. So quickly give me some random numbers. You? 48. Next. 60. Next. Huh? 29. You, Ethan? 30. Andrea? Louder. 50. Last one. What's the last number? At the other 100. So somebody find what's the last number? Calculator. Is it? Are you sure? 200, right? More than that? I don't know. Make sure you calculate correctly. Oh, those numbers. So negative 1, 1. Okay. So if you have 6 data points, okay, from 6 data points, n minus 1, you have only 5 data points that is free to move, which means that degrees of freedom is 6 minus 1 equals to 5. You understand why now? If you have 6 data points, the moment you put in the 5th number, the 6th number is fixed for you by the equation. It is no longer free to move. Okay? That's why it's n minus 1 in this case. May not always be. Some can be n minus 2 as well. Okay? I can say that the average of the 6 numbers is 100. Then it's still the same. Once you have the 5th number, the 6th number is stuck for you. This is what degrees of freedom means. Now, degrees of freedom is actually one of the toughest part of statistics. But once you get it, it's fine. So now your degrees of freedom. Now, in order to find the critical value for T distribution, you need the alpha and the degrees of freedom, which is 19. So in this case, you go to your T distribution table. Because the alpha is a constant number. So we cannot give you every single alpha value like in your Z distribution table. So in your T distribution table, it only calculates the regularly used alphas. So you go to the column alpha equals to 0.05, that second column. Degrees of freedom is V. So you go to row number 19 and you get 1.729. Okay. So it only calculates the regular alpha value for you. Based on this, what is the interpretation? Do you accept or reject null hypothesis? Fail to reject, correct? Because say that since the T statistic is less than the T critical value, you fail to reject null hypothesis, and you accept the null hypothesis. Therefore, there is insufficient evidence to fix. So same thing here is a 10-mark question. Okay, but how we distribute 10 marks is still here 1, 2, 3, 4. But we tend to give you 1 mark for degrees of freedom, assuming you get it right. 5, 6, 7, 8, 9, 10. Okay. So anyway, the good thing is, or rather the good thing or bad thing. The bad thing is you probably be the last batch that learn how to do the calculation by hand. Next year, you're not going to teach the calculation by hand already. Just going to use a computer to do it. And then interpret the results. Okay. So this is question 4. So far, any problem? Okay, next we try to do question 5. Question 5 is a two-tailed test. Okay, question 5 says Durian company launches its new iPhone. Durian, okay, claims that the battery life is 22.3 hours. Okay, private company thinks that it's not 22.3 hours. So acquire 45 sets, and the average that it calculated is 21.9 hours, with variance to be 25 hours squared. Okay, so the question is, is there sufficient evidence to say that the average battery life is not 22.3 hours? So same thing. Now hypothesis. Average battery life is 22.3 hours. The rival company thinks that the battery life is not 22.3 hours. That means it can be less than 22.3 hours or more than 22.3 hours. Just claim that it is not equal to 22.3 hours. So when you have a two-tailed test, automatically your alpha is 10%. Okay? In this case, it's 10% significant, 0.1. You automatically, if it's two-tailed test, you have to divide the alpha by 2 in order to use, because you're considering both ends. Step 3, you already have the data. N equals to 45. Mean battery life is 21.9 hours. That variance is 35 hours. Okay, which test you use? Either which test you use? Right. Why? Sample size is more than 30. So you use your Z test. Right. Step number 5. Complete your Z statistic. Who pop up things for me? Okay. So you have minus 0.537. Okay. Now, since your normal distribution is symmetrical, all you do is you do an absolute on both sides. Now erase this. Because it's symmetrical. Okay, number one mistake they will make is we give you variance, but the equation asks for standard deviation. Dimension square root of 5. So step 6, the Z 0.05 is actually 1.65. Just now we calculated already. Okay. So this is your critical value, or you can just write out. Accept or reject null hypothesis. Two, right? So, yep. Since the Z is less than the Z critical, you will do reject the null hypothesis. Since you accept the null hypothesis. Therefore, insufficient evidence to say that okay, so this is your answer. Now I roughly show you how I allocated the marks already. Another way that I can allocate the marks is this. You realize that when I allocate the marks, I tend to go from bottom to the top. So I look at these two values first. If these two values are correct, most of the time the front is okay, still all right. You get most of the marks already. Yeah, can depending on which side I read through. The worst thing is after you do everything, the interpretation is wrong. What happened? So what happened is you everything up to step 6 is correct, but step 7 is wrong. What happened? Do you get 3 marks deducted or do you get 0 for the whole question? I guess. So let's say you up to this point, everything you get it right. But instead of doing question 7, so this is the correct version. Actually, this is what you wrote. Assuming that this is what you wrote. You say that since Z is less than Z critical, you reject your null hypothesis, and so on and so forth. how many marks will you get? Yes. You get this wrong, I'll just give you a big fat cross and give you a 0 here. I don't even care about the rest of it. Why? Simple. Imagine you are doing an experiment. You do every single step and say that finally your pH of your solution is 4.7. And you say that this is your favorite answer. If for whatever reason you say that since your pH equals 4.7, therefore the solution is basic. Do you think you get any marks from here? I don't care what you do, you get it wrong already. Yes. What? No, you don't. We divide by, because it's 2 test, so you divide by half. Okay. So usually I'm not so evil most of the time. Most of the time, right? So it also means that when you check your answers, go through the important points. That is number one. Second, make sure you write legibly. Okay. Your 4 and your 9, make sure it's readable. 2 and 7, make sure it's readable. If you have extra time during your test, go and highlight the answers that you want me to see as well. Yeah. Highlighter lah. Why not? You highlighter and highlight. It's fine. Yeah. Talking about correction tape, in fact, all of you should just throw away your correction tape and correction fluid. Never use it in your life. Yes, don't use it. Okay, it's going to be a very serious problem if you use it in hospitals. Yeah, imagine when you are doing your MP in hospitals. Let's say if a patient have a misdiagnosis and ask for the medical report. If the medical report comes out, you have highlighted your liquid paper here and there, you are going to get sued. Yeah. Whether you change the results or not, nobody cares. Okay. Okay, so this is question 5. So question 6, question 7, somebody will do. I'm sick of doing already. Okay, question 6, question 7. Okay, then go and do question 6. Question 7. Okay. Okay, split your board into 2. Do question 6 and question 7. Yeah. Yeah. Split half. Do question 6, question 7. Yeah. Or you do whatever way, make sure it works. Question 6, question 7. Question 8. You split the board a bit more. Question 8. Question 8. Question 8. Adi, you do question 8. Okay. Why are you so tall? Like this. Thanks, like this. Question 7, question 8. Okay, yeah. Easy, but just write that. Okay, so question 8 on the other side. What? This one is population standard deviation. Huh? By right, you still unable to accept hypothesis. The end conclusion is either not hypothesis or not hypothesis. The practical conclusion is if you reject non hypothesis means not hypothesis. Right? There is still other hypotheses that may be true. At the moment, we still accepting dialogue. Make it simpler. Huh? It depends. Yeah. Okay, let's see. Question 6. Very good. Yes, that's correct. Okay, question 6 is right. Okay, I think this is a bit dangerous, because here you make sure you do absolute first. Okay, because this will always be true. What happens if it's minus, let's say minus 3 point something? Okay, so you have to do absolute here. Then the rest is true. But no, you will not. But what happens if you reach here is the conclusion is, for example, if let's say the t eventually ends up with minus 3.1, so you get the wrong conclusion here, correct? Yeah. Because absolute 3.1 minus 3.1 is still 3.1. Then you'll be you reject null hypothesis instead of you to reject. Okay, so if you're okay, then question 9, the the Z statistic is 3.1. You reject null hypothesis. That's for question 9. Yeah. Question 10. Okay, so for question 9, now you end up with the Z statistic is about 3.01. The critical value is 0.025 equals to 1.96. So you end up with, you reject the null hypothesis. Okay. For question 10, because the sample size, you actually the standard deviation is actually not known, so you have to recalculate it, which means that you get a T statistic of 1.23, 0.025, degrees of freedom 9 is 2.262. You fail to reject the null hypothesis. This is for question 9, question 10. Another common error that most students will make is you round off things too quickly, too early. So you know, for secondary school, if you round off too quickly, you're going to have all that error forward. Okay, so also be extremely careful with that, because think about how many different ways I can be a bastard. How can I be a more sophisticated bastard? I can get, in order to become a more sophisticated bastard, what I'm going to do is I'm going to give you the data to be so close that you calculate your T statistic to actually be very close to this value. That means maybe you get 2.601. Then if you kind of let's say the denominator, you round off the value too quickly, you're going to get a wrong answer. Okay. How fun is that, right? Okay. So if you think about it, question 9 itself, let's say for question 10. Question 10, this value comes from 10 data points. Right? I can use Excel to play around so that these 10 data points gets you a value of very close to the critical range. Okay, let's see. Question 7. Question 7. 3. Jesus. Hypothesis and 3. Right. Okay, 17. 3. Is that yes? Okay. Da. 0.01. How you get this part? Okay, this part here. To do absolute, this will be equals to 1.4551. The critical value is supposed to be 2.33. How do you get this? Yeah, you read the wrong side of the table. Okay, so automatically this is wrong already. So you actually see this from the axis itself. When this is supposed to be the area. So don't read wrongly, yeah. Okay. Alright, this is the main part. You have to realize, see each other's mistake and make sure that you don't commit a mistake during test. Okay. Okay, so the question 1 is true, true, false, true, true. Oh yeah, your term test, there will be MCQ, short answer, and one long question. And usually the long question is by me. So we all have to set some MCQ, and I really decide to set MCQ because I don't know, it's hard to think of all the wrong answers. But because I got set MCQ, I got to think of all the wrong answers. My wrong answers is pretty crazy. So most people in BDA or in statistics, they do badly because they screw up the MCQ. Okay, so please read carefully. We do have students that get all 10 MCQs wrong. Yeah. Well, as you know, the more MCQ I set, the more statistic I become. And that's what happened. But don't worry, Poly MCQ is still doable. Wait till you go and do Uni MCQ, then you die from it. Oh, simple. No, Uni MCQ, Poly is only A, B, C, D, right? Uni MCQ can go up to J. Yeah. Yes. No, because it's set over multiple years. So you keep adding question, adding question, adding question. And the 10 choices could be you have, let's say, 6 statements, and one of them could be none of them is correct. Statement 1 and statement 3 is correct, but statement 4 is wrong or it's rubbish. 1 minute per question. Yeah, sometimes. Yes. Yes. That's how you kill people. Okay, so that's all for today. Let me finish my recording first.